Bismillahirrahmanirrahim. Assalamu alaikum. Okay, let's continue with the coordinate geometry session. And in the previous video, we have calculated the gradient for AB. We have calculated the length of AB, and we have also seen that the equation of the line passing through the points A and B is y is equal to x minus 1, right? Now I have added two more lines, horizontal line and the vertical line. The horizontal line is passing through A and C, and the vertical line is passing through B and C. Okay, now let's find out the gradients for the horizontal line and the vertical line. We can very clearly see that when we talk about the horizontal line, in this case there is no change in the y value. If A has the y value as 2, the same is true for C. So when the line is horizontal, it's not rising or it's not declining, so it's passing through 2 points A, C, and the value of the y remains the same. So let's see what the gradient is in this case. Gradient of horizontal line passing through AC. So the gradient is y2 minus y1 over x2 minus x1, which is 2 minus 2 over 7 minus 3, so it is 0. So the gradient for the horizontal line is 0. The reason is there is no change in the y-axis point, right? Now let's talk about the vertical line. In the vertical line, we can see that the y-axis values points are changing, but there is no change in the x-axis point. The x-axis point here is 7 and here it is also 7. So there is no change in x-axis point, but there is change in y-axis. Let's see what is the gradient for the vertical line. So if we see here, it is minus 4 over 0. So it is undefined. If anything is divided by 0, it is undefined. So we are not going to say that the gradient of the vertical line is undefined. What we are going to say is it's a line passing through a certain point on x-axis. In this case, it's at 7. So x is equal to 7 is the equation of this line, and it is giving us the idea that the gradient is undefined, but this line is having the same value for x, no matter what is the y value. Okay, now let's find the length of BC and AC. And the formula we are going to use is the same. Okay, we have calculated the length of BC, which turned out to be 4, and the length of AC, which also turned out to be 4. And in both the cases, we can see here, there was no change in the x-axis, there was no change in the y-axis. Okay, so we have the value for both this A, C and BC. It is 4, and this we already calculated, which was 5.66. Okay, now there is one more thing. If we see here, this triangle ABC. Now this is a straight line, so it's making 90 degree with this. So here we also have a Pythagoras theorem. Okay, so let's apply the Pythagoras theorem and let's see what value for the hypotenuse we get if we have AC equals 4 and BC equals 4. Let's do that. Okay, if we see this triangle ABC, this is a vertical line, so it's making 90 degree angle with AC. BC is making 90 degree angle with AC, and this AB is, since it is opposite to 90 degree, so it's hypotenuse. So we have applied the Pythagoras theorem here, which is AB square, hypotenuse square is equal to AC square, which is base, right, adjacent side, or this perpendicular, BC square. So AC square plus BC square, and we have here is 16 plus 16 equals 32. So AB is equal to 32, and we have already calculated 5.66. So you see, we have applied the Pythagoras also, and it is confirmed that what we calculated through the graph is also through the Pythagoras theorem. Okay, now let's do one more thing. If let's say we have a perpendicular line to AB, what happens then? Okay, we have another line PQ, and the gradient for PQ equals y2 minus y1, sorry, mistake, it's 1 and 8, okay. So 4 minus 8, and then x2 minus x1, 5 minus 1 equals minus 4 over 4, which is minus 1. Now the gradient of AB is 1. If it happens that if M1 into M2, which is M1 is the gradient of line 1 and M2 is the gradient of line 2, and if it is equal to minus 1, it means that both the lines are perpendicular. So here in our case, M1 is the AB, gradient of AB, which is 1 into minus 1, which is the gradient of PQ, is equal to minus 1. So it means that the two lines are perpendicular. The condition for two lines to be perpendicular is that if we multiply their gradients, gradient of AB multiplied with gradient of PQ, the result has to be minus 1. And in this case, 1 into minus 1 is obviously minus 1, so both the lines are perpendicular. Okay, once again, this is a freehand drawing, not scaled properly, and if it is drawn on a proper graph paper, you can have the better drawings, right? So it is just a freehand without any measurement drawing. Remember that, okay? So thank you very much for now, and hope you got the idea of this coordinate geometry, and try to explain the gradient of a line, straight line, and then how to measure the length of a line segment, and then we check the slope of the horizontal and the vertical lines, and then how to get the equation of the line. We have all seen through this simple drawing. Okay, thank you very much.